Well, welcome back to our course. This is going to be the first of two modules where we're going to be getting into some specific programming. We've been introduced to CNC systems, CNC controllers, looking at some other details, and now we're going to get into more specifics. So let's go ahead and actually do the programming. So first, to be thinking about what we have in this module, in this chapter that relates to this module. First, we'll be talking about code words and program conventions. Then we'll talk about the outer program structure, things that we want to be thinking about for conventions for our programming, how we do things manually, compensated cutter paths, writing ARC commands, and finally writing auto-compensated programs. So we'll break this up into parts, but let's go ahead and start with these first sections of the code words and outer program structures. So just a couple notes. We'll be learning to compile command codes either using YCC, a control keyboard, or a text editor. And some would argue that so few programs are written by hand today. Why take the time to learn such a time-consuming, error-prone skill? And some would argue it's a valid point, but these are the things that you want to make sure you understand the details. So if you get a canned program, you're going to know how to operate it. And so here, but first, when we set out to compile this text, our focus planners took a hard look at technologies made clearly obsolete by CAD, CAM, and CNC. If they prove to have little value for today's machinists, we remove them. Be assured hand code skills are included here with careful consideration. So we'll be actually demonstrating that with some of the project work we'll be doing in class, and so you'll see about that. So the textbook and the authors of it are trying to be looking for what a machinist would need to know, what a master skills person would have, and then finally for the role that you have as an engineer in guiding that whole process. And so you need to be familiar with everything that would be related to that. CNC machine troubleshooting programs to solve error messages. They edit bugs or write improvements to make programs safer or more efficient. During setup, commands are punched in at the controller to make or modify tooling and to move the machine by manual data input. All these key steps require code reading and writing mastery. So from a shop talk point of view and programming, many machinists aspire to programming after running the machines for a time. A working ability with codes is a must for that job. So you'll be encountering that in one form or another. Okay, so getting into some of the details that we have for this module, let's look at the codes and conventions. First, we'll examine a baseline vocabulary. Then we'll investigate data conventions, how to make entries the control can accept. Next, we'll look at a set of command words to begin programming safely and how to end them too. So the syntax as well as the commands are important. And lastly, we'll learn programming structure and how to join the code words together into complete command blocks. So a trade tip for memorizing, then the main objective is not to memorize codes, although doing so will accelerate mastery. So most likely you're going to have a handbook for helping you to code a specific machine. And so we'll be having some similar constructs with our project work. And so the goal is to learn to be aware of the possibilities of what you can be doing. So terms that we'll need, the alphanumeric code, you'll get a chance to see that. The command, and this is the actual thing that's listed on the command line, the command word, code groups, preparatory codes or G codes, M code words, and modular commands. So codes to commands, a command line in a program is a complete set of instructions to be acted upon by the control. It is composed of the alphanumeric code word, coordinates, and numbers. Turn to the list about 6 pages into chapter 21, scan down to the selected set. So you'll get you have an example in the textbooks of a variety of commonly used commands. As you can scan, note the way they are grouped. Groups are mutually exclusive. You can only use one from the group of G words or M. For example, group 1 cannot move at G01 feed rate and G00 rapid travel at the same time. Most are modal. When they are called out in a command line, they remain in effect until canceling or replaced by another from that group in another command line. So what we're going to talk about is nearly universal. Those code words come from a set that was written before machines had microprocessors with random access memory, RAM. They could read codes and act upon it, but not use variables on the fly, such as offsets. As such, the 50 core G words and 50 M words survive from those early codes. They cause simple motions such as feed rate linear or two-axis circular motion. They are standard codes everywhere. So that's what we're starting for a basis here. But the EIA originators, government entity that invented government and company entity that invented these, could foresee that there would need space for expansion. So they left 50 of the first 100 code words blank in both the G and the M categories. Today, all of those code words have been filled. Some have become nearly universal CNC codes due to their use on various types of controls. But today we have gone far beyond 100 code words in both M and especially in G words. So this basic set is fine for the unit and for most hand compiled programs for machine setup. And so that's what we'll be focused on. And missing codes in the vocabulary either too higher or for higher functions, or they are machine specific custom code words. Okay, let's get into the next subsection. Programs are divided into three portions. They have a start, they have a body, and they have an end. Even CAM-generated programs need beginning commands that set conditions or cancel unwanted modules left over from the previous program. End codes close certain modes and actions at the program end. So for communication file labels, some controls require specific codes and labels as the first program line. Others do not. To find out, read a program from that machine or read the programming manual. So here, first, I'm talking about some generic startup commands as suggested. Only here's a typical startup set of commands. And so we have G80, G40, the cancel cycles and compensation, G70/G71, inch or metric values, G90, absolute values, G91 would be for incremental, G94/G95 is the feed IPM or IPR, XX sets the feed rate for the first cut, SXXXX is the first RPM, and G17, G18, G19, these set the active mill plane for interpolation and comp. RPM and feed rates can also be later in the program, but they must be entered on or before the line where they are used in the command. There's no harm in placing them at the header of the program. So we're getting into some programming style here. And so in general, you'll have a specific set of safety and startup codes required for the controller and the situation that you're going to be dealing with. For retract distance, this is another area where your instructor, say when you're out in the lab, things that we'll be doing as we're thinking about the limited capability with our project tools, we'll set a policy as to how to close to the work. New programmers can rapid their cutting tools. A ½ inch is a good distance, but may be too close, especially for larger turning centers where crashes are spectacular. So a safe distance to rapid travel to and from. Here we see a little graphic here. Safe distance to rapid travel to and from. You can see an illustration of what that could look like. Okay, we'll go ahead and take a little bit of a break and I'll come right back and continue.